Hi, in this particular section, we're going to be talking about non-parametric tests. When do we use non-parametric tests? Before we talk about non-parametric tests, we need to know what non-parametric tests actually are. So, statistical tests that usually make no assumptions about the distribution population, they are usually referred to as non-parametric tests. All the tests we've actually been referring to previously are actually parametric tests. You might have noticed that I'll be talking about assumptions, a set of rules that data have to obey or have to follow for us to be able to use a particular test. So non-parametric don't actually have any assumptions, so they're usually used when your data fail those assumptions. So the key characteristics of non-parametric tests are that they're distribution-free methods. Most importantly, your data doesn't have to be normally distributed for you to use a non-parametric test, and most of the times they also use ranks or signs instead of the raw values, and they are more robust to outliers and also have a lower statistical power than parametric tests. So a lower statistical power means that the study actually have a smaller chance of detecting a real effect, even if an effect truly exists. So this is just what we're trying to explain. So parametric versus non-parametric tests. So parametric tests usually assume normal distributions, and also they use actual values, and they are more powerful when assumptions are met, and they're also sensitive to outliers. Your data has to be normally distributed for you to follow normal distribution, have the shape of a bell-shaped curve for you to be able to use parametric tests. Also, in terms of parametric tests, we usually use the actual data values. So the values that we got from our observations are what we actually use in terms of parametric tests. So parametric tests are usually more powerful when the assumptions are met, and are usually better. If your data meet the assumptions, then it's better to use a parametric test. But if they don't meet this, where you now decide to go for non-parametric. They're also sensitive to outliers. So that means when you have a particular outlier in your variables in the data, then they're likely to affect your results. So non-parametric tests, they actually know distribution assumptions. They use ranks or medians. So you either use your ranks or your medians from the data, and they are usually less affected by extreme values, since we are not actually using the actual values, we are using their ranks or signs or their medians. And it's usually suitable for ordinal data. So ordinal data is the data that usually have factor variables, and these factor variables are usually ordered by level. So typical example of the ordinal data, for example, you can have size, low, medium, high. So these are ordinal data. So when do we decide to choose a non-parametric test? So you should use a non-parametric test when, first of all, your n is less than 30, when normality is uncertain. So you have a sample size, small sample size, and you are now sure that your normality is likely to be uncertain. You are not sure that your data is normally distributed, or the curve that you decide to plot is not actually close to a normal distribution. So then secondly, when the data is not normally distributed, this is either when you have confirmed by test or plot, you found out that your data is not actually normally distributed. If also your data contains outlier, then you should decide to go for a non-parametric test. Your data is also categories that are actually ordinal or Likert case, then it's best, which makes it easy to rank, then it's best to go for a non-parametric test. And also, if your variance assumptions are violated, heteroscedasticity, so that means you have unequal variances among various variables, then you need to go for a non-parametric test. And also, after transforming your variable, you still find out that it doesn't normalize the data. Maybe you take the log of that particular variable, for example, now, and you plot that particular log of those values, and you found out that the data is still not normally distributed, then it's best to go for non-parametric tests. So there are various ways of checking for normality. You either use histograms, or use the QQ plots, or use the box plots. On statistical tests, we already talked about it. You can use the Shapiro-Wilk test, or the Kolmogorov-Smirnov, or the Anderson-Darling test, whereby if p is less than 0.05, then you reject the null hypothesis. That means that particular data is not normally distributed. So what are the common non-parametric equivalents? So for one sample t-test, we have the Wilcoxon signed rank test. And the purpose is usually to, just like the one sample, to compare samples to a hypothesized median. In the one sample test, you want to know if this particular sample has a mean equals to an hypothesized mean. So, but for the Wilcoxon signed rank, we want to try and see if that particular sample has a median equals to an hypothesized median. Also have the peer t-test, whereby you compare paired observations together and see actually if they are equal or not equals to each other. So you can use the Wilcoxon sign rank test as an alternative to the paired t-test. We have the independent t-test. Also, when you want to compare two independent groups that are not actually paired, you use the Mann-Whitney U-test. And for a one-way ANOVA, whereby you want to compare variables that are more than 2 to find out if they are significantly different from each other or not, you use the Kruskal-Wallis test. Or that you have variables that are more than 2. That means this can be 3 and above. And Pearson correlation, the alternative is Spearman rank correlation. So from the name Spearman rank, you know that it is actually using the rank of the data and not the values. So this is usually used for measuring association in continuous variables. So advantage of non-parametric tests. So first of all, you have fewer assumptions. It requires fewer assumptions compared to parametric counterparts. It is also robust to outliers and skewness. That means it doesn't care whether the outliers or the distribution of the data is actually skewed. It can also handle ordinal data, and it is valid for small sample sizes, and it is easy to understand since it's usually based on ranks. So, but the trade-offs are usually the low statistical power, which I already explained earlier on, if the data is actually normal. So, this low statistical power means that a study has a smaller chance of detecting a real effect, even if the effect truly exists. The chance of parametric test detecting statistical significance is higher compared to that of a non-parametric test, and also it may miss subtle effects. If the effect is very minimal, but there is effect, so a parametric test is likely to capture that compared to a non-parametric test. And also, some people are not also familiar with non-parametric tests compared to how popular parametric tests are.